Welcome to another SME Media webinar. This webinar is titled, How to Make Self-Driving Equipment Work for You. It's sponsored by Vecna Robotics. Autonomous material handling equipment such as self-driving fork trucks, pallet trucks, and tuggers are becoming a common sight on the factory floor. These vehicles can improve efficiency. In today's webinar, Andrew Jackson of Vecna Robotics discusses what autonomous mobile robots are, how they work, and how they differ from other automated equipment. The presentation will examine different kinds of automated platforms. We'll also examine what the deployment of autonomous mobile robots into a facility looks like. During the presentation, you can ask questions. Just use the Q&A box on the side of your screen. We will collect the questions and go over them after the conclusion of the presentation. So now, here's Andrew Jackson of Vecna Robotics. I'll be back later to moderate the Q&A session. Take it away.
Hiya, folks, and thanks for tuning in with me today. We're here to discuss material handling and specifically autonomous material handling transport vehicles within our automation spaces. So what are we all doing here? Well, I think we all live in the same world together, right? About a year ago, everything went a little bit crazy, a little bit hanky, a little bit off the rails, and we all saw e-commerce tick up to a level that we didn't think was going to happen for about 4 or 5 years. This put a whole lot of demand on the system. Supply chains were disrupted, manufacturing was disrupted, and now everybody's looking to find solutions to future-proof their applications for if it happens again, to make sure that they can meet current demand, and to make sure that they can deal with the rising costs of labor shortages and the cost of onboarding folks constantly because you have to retrain them and things like that. So what does it take to be successful in this space? A lot of times what we've always done is the right way to do it, and it's the way we've always done it this way. But as you can see, Forbes calls that the most dangerous phrase in business, right? And why? Well, it's not to villainize change or the lack thereof. It's specifically to make mention of the fact that we always need to be thinking about just how we're doing things today, but how those things are going to adapt and overcome to the challenges of tomorrow. And if your current process is great, fine, manually operated, and it's getting your throughput numbers out the door today, that's a great thing. Congratulations to you for being able to maintain that, the uptick in demand out there. But what we're talking about is, will that be able to handle that capacity or more capacity in the future? What are the current headaches that you currently find in your way of doing it manually? And how can AMRs, VGVs, and AGVs address those concerns and challenges, not only today, but in the future? And so let's dive right into it. Start learning some things together. My name is Andrew Jackson. I'm the industry sales manager over here at Vecna Robotics. We produce high-capacity AMRs for material transport within the space. I've been doing general automation for about 15 years, starting with the sensor company, and then moving my way all the way up to a certified machine safety expert, where I was conducting and doing risk assessments and integration remediation for various different types of automation pieces of equipment, inclusive of AGVs and AMRs within manufacturing spaces. The marketing people have put a bullet point that I'm a remarkably likable guy. I would say that that's a jury question. Some might have a different opinion more than others, but I'd like to think so. And while I am not the president, I do share his namesake. Unfortunately, at this point in my life, I'm not giving $20 bills out with my business card. But it would be really cool, and I would like to get there someday for sure. So what are we all doing here, folks? We're trying to figure out how to make self-driving equipment work for us. It's scary, but it's fun. It's challenging, but it's rewarding. And right there, we're on that teeter-totter. Do we or don't we, right? So what are the different types of automated platforms and how do they work? How do you know if you have the right application for an autonomous vehicle within your facility? And what are the questions that you need to be asking yourself for that? And what does the actual deployment of these vehicles look like in your facility, right? This last one is going to be a big one, right? How is your current operation, the way you've always done it, going to change? And how are you going to get the people within it to come along with you down that journey rather than throw their fist in the air and say the robots are coming and I'm scared of them and so on and so forth. So it's best to start with the platforms. And historically, AGVs have been the prime mover of things within our facilities. Now, AGVs are considered automated guided vehicles. And while automated, they are not autonomous, meaning that they are path followers. A path follower means that there is a piece of magnetized tape on the floor, or in the floor, there's actually a little magnetized puck. And there's actually a sensor on the bottom of that AGV that's looking down and following that magnetized strip. It does not deviate left or right. It does not come off of it. If it does, it needs to be put onto it. That magnetic strip is the material superhighway for that AGV to go from its point A location to point B within the facility. Now, that's not the sensor that's actually keeping that AGV safe. There are sensors that are on the ground level that are looking for obstacles in the AGV's path and telling it to stop or slow down when it sees certain things. There are also other ways for AGVs to navigate via laser targets that are fixed to the ceiling and the walls. And you use triangulation. So spinning laser is bouncing and looking for a time of flight to come back from 3 separate sources, therefore giving it a position within a path that it knows that it's already on. Or you can use barcode readers, right? Vision systems have progressed to the point where you can lay out barcode readers, barcodes all over the place, and the vision cameras on the AGV will actually pick them up, and those barcodes will tell that AGV what to do. So how do you navigate through the facility? You follow the path that is hard-coded within the facility to get there. Now, the vehicle itself is low cost. So what's attractive about AGVs right up front is if you've got small couple 100-pound capacity that's just going from point A to point B, that's never going to change. It's like a QC inspection station to the warehouse for put away or something like that. It's couple 100 feet straight there, straight back, and it needs to take a few boxes or whatnot. Maybe an AGV is right for you, right? Because the vehicle cost is low and the infrastructure from point A to point B isn't really all that much. However, the infrastructure installation is time and labor to get up and running. So it takes time to put all these magnetic strips or pucks in the floor, the laser targets on the wall, to tune the robots in to find out where they are, get them on that path and follow them. And all of that equates to time. What are we doing here, folks? Time is money, right? So that's what we're looking to save a little bit of is time, and therefore get the money savings. So they've been around for 50 years. You can find AGV manufacturers who will pick up massive loads, on the order of 5 or 6 tons, right? And AGVs are really good at moving very, very, very heavy things because very heavy things don't need to move freely in and around operators. So if I've got a 50,000-pound calendar roll of metal, I certainly don't want my AGV stopping and planning a path around somebody who's standing in front of it. I'd rather the person just get out of the way, right? So AGV has kind of usually been called a prime mover in the past, meaning that we use them for customizable applications, and we use them for specialty things, not just necessarily moving pallets from point A to B or roller carts or things like that. They are best suited for air transport with no obstacles. There is no ability for an AGV to clear itself around an obstacle. You're going to have to do that for it. It needs to have that infrastructure clean and available at all times. So you're going to have to clean off of those laser target reflectors on the walls. You're going to have to make sure that the magnetic strip tape is in good working order, that there are no tears or cracks or no breaks in the magnetic lining, or you're going to have to rip that up and replace that. So over time, while you bought a low-cost vehicle, the lack of being able to change the route without having your AGV company come in and give you a change fee, or the lack of or the need to go out there and and maintain the infrastructure all the time is where the cost creeps happen. So we're susceptible to environmental conditions on the floor. We don't move around obstacles. We're A to B transport. If you want to change the AGV route, you're going to have to shut the AGV down. You can't just reprogram it, retask it, lay some different magnetic tape. Your service provider is going to have to come in and do that for you. And there's going to be a change fee cost associated with that. That's why over time, AGVs, while low cost up front, cost more in the long run. Just all the upkeep stuff that you've got to keep doing on them. So good for small A to B applications, good for tight corners. However, larger aisles are usually recommended because of pedestrian traffic. Remember, we can't move in and around space with other people, right? So you want to make sure that the people have enough space to keep away from the AGV while the AGV also has enough space to do its thing within the aisle. So you're going to typically need a larger aisle than is normally given for something like a VGV or an AMR. So I said VGV. What is VGV? Visually guided vehicle. I love visually guided vehicles, man, because they just make sense to me. They should make sense to you because you've got a set of eyes too, right? So a vision system uses cameras to see. And what it does is you get on the truck and you drive that truck through a specific area in teach mode. And it's recording the video, right? High resolution digital images are coming back. Within those digital images are ranging information. So that's what you see with all the little dots in the picture there below. But what people like about VGVs is their ease of use and ease of programming, and their ability to translate what spatially what the visually guided vehicle sees to what they see also in their facility. So they are easy to be reprogrammed, so they make themselves versatile. You drop them in there, you drive the truck on the route, boom, it's ready to go. It picks up, it drops off, it picks up, it drops off, you're great. But that reprogramming there is also ability is there also for another reason, which I'm going to discuss on the next slide. They're best used in facilities that don't have a lot of lighting changes. So vision, right? If you look into the sun, you have to squint or shut your eyes. Well, the same thing with the camera. It's going to get blinded by light. You're going to want to make sure that the lighting in your facility is consistent at all times, that you don't have that window with at 2:30 on the eternal equinox or something. There's that beam of light where the VGV is going to drive. It's going to shut itself down. It's going to say, wait, my cameras can't see, so I cannot continue. Come get me, help me. And that will be done through, a light stack or an audible horn or something like that, right? But most importantly, with respect to VGVs, one of their limitations is that they are not great at getting around obstacles or major changes that disrupt their environment. So if we get a lot of sand in our eyes, we blink a lot, and we clear our eyes, but it still hurts, and we can't really see as well because they get all watery and everything. Well, it's not the same way with the camera, but if you got dirt or dust built up on the camera lens, you're going to have to wipe it off because that camera's going to fail to be able to bring back those high resolution images. So too is the actual picture that the visually guided vehicle is taking. So you've driven this route, and along this route, you've seen this video, and this video is now being compared in real time to the video that you're taking, that the VGV is taking each time it takes the route. At 2:30, at the end of end cap 1, 2, 3, for the right-hand turn that the VGV normally makes, you put two high stacked pallets that are side by side, right? Essentially creating a longer corridor on the right-hand side at the end cap and lessening the angle of attack for the VGV that would normally make that right-hand turn. The VGV cannot therefore understand its localization and will most likely need you to reprogram that route, or will need you to help that vehicle make that turn on that route. The reason is because you've elongated the corridor. So now you've changed the picture and the program pictures don't match up. So if there's an obstacle in that path, you're not going to be able to get around it. You're going to need to assist the vehicle. But if you change anything significantly within a VGV, this is where that reprogramming feature really provides that benefit, because now you're going to need to go back to that vehicle and not only assist it back onto the map, but you might need to redrive that route, taking that time to reprogram that. And you're going to have to do that multiple times throughout the VGV's operation within your facility if your facility changes from time to time. So frequent reprogramming presents localization problems for visually guided vehicles. Vision systems affected by the same things that our eyes are affected by: dirt, dust buildup, lighting issues, and things like that. Over time, what you're looking at is just more touches on the vehicle, more interaction with a piece of automation equipment that you've bought. Some people like that, some people don't. AMRs. So we had autonomous, automated guided vehicles, right? These are not automated mobile robots. They are autonomous mobile robots. And the difference between automation and autonomous is kind of a really big deal to us folks in the AMR world, right? We are meant to be seen as intelligent pieces of automation equipment that work in and around personnel and operators, right? So we are taking the same paths and aisleways that people would normally walk in. We are able to dynamically adapt to what's going on in those paths and aisleways. Now, we typically see people think of AMRs as little bots, the ankle biters or the knee rackers that are coming around and they're jacking up a rack that's on wheels and bringing it to a pick station, or they're bringing totes or little bins of things to the line or something here and there. AMR technology is capable of being in a small package, right? However, it has been adopted by some companies to move high capacity materials, so 10,000 pounds or more horizontally through the facility, and now even vertically with stackers and reach trucks, right? So an AMR provides you an intelligence, but also provides you that high capacity, or can provide you a small little bot format, depending on who you're choosing as your provider. Now, we're going to talk later about the use cases that you have in your facility, and then those are going to dictate what kind of vehicle that you need. But what you need to know about AMRs is the intelligence allows them to maneuver around obstacles, and that's the first way an AMR is able to recover itself within an automation use case, right? It does it itself. It looks down the line, it says, oh wait, about 20 feet in front of me, I see something that's not supposed to be there. That's my normal path. I look left, I look right, I see space on the right-hand side. Okay, I'm going to initiate a turn around this obstacle, just the same way we would drive around something in a road. That's what an AMR is meant to do. They can often be supported remotely depending on the AMR provider that you choose. So what that means is that if that AMR can't recover itself around that obstacle, there is somebody who is sitting in a remote operation center who can teleoperate the unit back into working order. And they do this through a host of different sensor setups and suites. But what that means is now you've got two reasons that you won't have to go touch that robot, right? One, it's going to try and do it itself. Two, there's going to be somebody behind it that can remotely do that so that you can go on with doing the tasks that are more important to you. And the reason why you bought automation in the first place was so that you didn't have to make all those touches all the time. And those touches are time, which is money, right? So the intelligence of the AMR is the integral piece of the technology platform that you want to pay attention to. You're going to want to ask your AMR providers about how they utilize software for fleet management. You're going to want to ask your AMR providers on what kind of sensors they use to localize within the facility and how they create their maps and what can be done within their maps, right? So vision guided vehicle, or AGV, it's a path and it's a simple path. The VGV, you teach it route 1 and that's its route for the day. Now you can tell it and teach it route 2 over there, but that requires that reprogramming. With AMR manufacturers, we're looking at a more bird's eye view of the facility, let's say. And here we're going to show you a video of what kind of sensors are being used with an AMR and what this AMR is doing. The video that you're watching is actually an AMR in what's called the mapping phase of deployment. The AMR is being driven around the facility and it is collecting sensor data. These sensors are a host of a suite of sensors, right? It's not just one sensor that's giving all this data back. On the ground level, you have safety LiDAR safe systems. These are safety first priority sensors that allow the vehicle to navigate safely within the facility and around people. If they are encroached upon, the vehicle stops. And that's safety first navigation. It means it can't be overridden, and that primary safety bubble, as it were, around the vehicle is always there, and it is the primary consideration in the vehicle's movement. Above those is usually another LiDAR sensor, either 3D or 2D based LiDAR, which is then creating a forward-looking sensor array and bringing back those millions of points of data from a LiDAR-based sensor. Above that is what's called a localization LiDAR. And localization LiDAR is assisting in the upper level spectrum of view that the eye-level LiDAR isn't able to pick up. So it's looking over the top. And then what we're doing is we're taking all three levels and we're creating an entire picture, which is represented in exactly what you see here. This has been done, this video has been produced with the sensor data that comes back from the vehicle itself during the mapping process. Now, why is that so cool? Well, it's cool because it doesn't care about light shining directly in its eyes. It's cool because it doesn't care about dirt, dust buildup as much as a vision-guided vehicle would. Now, when these sensors become dirty or dusty, they actually have auxiliary outputs that can tell the operators, hey, you got to come clean me so that it can work better. Or dust is building up, which allows you preventative maintenance planning that's just built into the AMRs. These sensors also are looking out and they're trying to plan the path and plan to avoid obstacles within it, which means that the data that we're bringing back is not only saving the operators from safety incidences and things like the like, but we're also paying attention to soft stopping the machine versus coming up to something and just hard crank stopping it, putting a really big stress on our motors and our brakes, right? So we're driving around the facility, we're paying attention to everything that moves in and around it, and we're creating what you see here, which is a 3D map of the entire facility. Now, if I've got a map of the whole thing, I can plan and create multiple routes within the same map, and all of those routes can then be accessible by the various different AMRs. So there doesn't need to be an A to B route. It doesn't need to be as stringent as I drive this route, I teach this route, and this is now my route to do work. If there's already a map in place, then we can create those routes all over the place. And then we can dynamically choose which ones to follow based on all the plethora of data that we're going to get back as we work over time within the facility. So what are you looking at in your facility? First and foremost, what are you moving is the prime consideration, right? Are you moving pallets? How are you moving them? Are you using forklifts right now? What are your pallet conditions? Do you have A grade, B grade, European pallets, Chinese pallets, Chet pallets? What kinds of pallets are you moving? Do you have any irregular shapes? What are you currently doing to move irregular shapes? Are you just basically jacking them up on a fork truck and driving them to wherever they need to go, or using tugger systems in order to get where you need to go? And then most importantly, weight. What is the average weight of what you're moving? And that's going to dictate the class of vehicles you're going to be most attracted to and want to pay the most attention to moving forward. Next, distance. Ultimately, distance and time are so close together here that the equation of distance and time and the amount of time equals money is very easy for us to all understand. I think that's what we're really here to figure out today, right? Deadhead travel is non-value added. And what we call deadhead travel is you've got somebody that picked up a pallet at inbound and then they went to a put-away station and put it up in racking. Now they're coming back. Their forks are empty. So that's non-value added travel, right? You want to ask your AMR service providers how they overcome certain things like that. Can they do things like interleaving, which is the ability to pick one task at inbound and correspond it with another task close to where that inbound put away would be. So if I'm putting something away in aisle 1, 2, 3, and there's also something that needs to be picked up in 1, 2, 3 and brought to outbound, why not do that as well and do that through an orchestration engine that should be provided by your AMR system provider, right? What we are talking about here is integration with your facility's WMS, ERP, SAP systems, and the ability to get work orders in and predict what work orders need to be done is called interleaving. So something to definitely ask about. So how much time are you driving around with your forks empty, and how repetitive is that task? If you got a tugger driving around in circles that's currently manned, is the only benefit that person is also hopping off that tugger at every single station and performing a task? What automation equipment or personnel can you lend to that in order to get that person from driving around in that circle, and then let an AMR tugger or VGV tugger accomplish that same task, letting that person maybe do cart transfers or product transfers and such off on the cart, or go man a different vehicle within the facility. So for your people, multiple shifts. 2-3 shift operations should be very seriously looking about automation components being added within their material handling flow. You have multiple people on those shifts. So how many shifts and how you running people on them. And what that comes down to is how people work over time, right? So how are you working them? How does the job workflow utilize them, both ergonomically from a health and safety standpoint, but also from a life standpoint, like the benefit of giving somebody a more stimulating task makes employee retention easier over time, which decreases the need for frequently training new employees. Which decreases your turnover. If employees stay happy with the jobs that they're doing, then it's easier to retain them, which reduces your cost over time, right? So things to look at is how are you working your staff overtime if necessary to meet the demands? What are your turnover ratios? What's it cost to train people? Things like that are all going to be solved by using an AMR where that was a previously manned task. Lastly, AMRs are safe. And you want to ask a lot of safety questions about your AMR manufacturer or provider, right? But currently within your facility, are you accomplishing tasks with manual drivers? And how many safety incidences or recordables have you had in the last 3 years? What is the cost of those incidences and recordables? How often do you have to retrain drivers? How easy is it for them to not show up or call out sick? And then put you in a real tight position that day? How much time do you spend looking for supplemental workforce? And how safe are those drivers actually rushing around the facility? I mean, we all have speed limits and things like that, but when you get into the facility and it's getting done, and things need to get done, there are corners that are cut. I think we all know that, if we're being honest with ourselves. So safety is a big thing about the adoption of AMRs. So what to expect when they show up, right? An AMR typical installation is 4 to 6 weeks. And the reason for that is because of the extra things that an AMR manufacturer is doing. They are making maps not only just of Route A, but they're making maps of your facility. In this way, they're going to be able to provide you versatility in your route preference and your route choosing, the ability to take one route or another based on facility idiosyncrasies, right? Maybe on Wednesday, on the third week of every month, there is a shift change that also comes with a major machine swap out or some sort of CNC tooling thing, which requires a whole lot of heavy equipment to be in that route at that time. Can your AMR provider provide you with a secondary route that they can simply just click off? Because if you use the VGV, you'd have to reteach that robot every single time. But maybe it's just as easy as a button push on a tablet screen that allows you to reroute the AMR and secondary route. Remember, if we have a map of your entire facility, then we can go anywhere in it. We don't need to continually reteach routes within that facility all the time. So the equipment's going to show up, and so's a person. And that person is going to be highly trained from your AMR provider, and they're going to get on that vehicle and they're going to drive around the facility creating a map, like the one that I showed you previously and the one that you see on the right-hand side here. The new equipment will map the facility, and it will learn. In the process of doing the mapping, we're going to learn and start beginning to interface with your personnel about your automation workflow. Workflow optimization is the most important part of AMR adoption, next to training and adoption of the actual site staff and personnel. We don't want to come in and reinvent the wheel necessarily on how things have always been done, but we do want to come in and provide a benefit that allows the operators to understand and be okay feeling safe and secure around the AMR. And the only way to do that is to involve them in the entire process. Creating site champions, robot experts, doing naming competitions, making sure that everybody on every shift has a say in what they think or know, training everybody effectively and creating standardized practices in and around the AMR. All of these things are extremely important. You want to ask your AMR provider how they do this for you. So it is upon the AMR manufacturer to help you train and bring about the adoption. Lastly, fine-tuning your workflow. Training goes hand in hand with knowledge. The more training that is provided, the more knowledge comes from the operators to the AMR manufacturer, the better the automation use case gets installed and deployed. Ask the hard questions up front. Leave nothing to chance. You do not want to find out when you go live that there was an extra UI screen that was required, and then that takes down the entire go live event, right? All of those hard questions about the route, the shift changes, the idiosyncrasies of the facility need to be known up front. That way you're creating a partnership. Instead of buying an AMR, you are consulting with an AMR company, and they are training you on how to effectively apply this automation within your facility. It's super important, folks. I can't stress the fine-tuning of the workflow and the optimization of it comes from interaction with site staff, and it creates adoption. Super important. Please pay attention to this when you start your selection about AMRs within the facility space.
Hello, this is Bill Koenig again, and we are back with some questions. So hope everybody's ready, but let's get started. I'll go to the top of the queue. Does the technology permit the automated systems to be interlocked with the fire alarm, not sure this word, annunciator panels for an emergency stop?
Sure, that's a great question, Bill. Thanks for asking. I can answer this from the Vecna technology side. I can't answer it from all AMR supplier side. I'm not familiar with whether or not they've built out this specific feature. But Vecna Technologies and Robotics offers a specific add-on feature called the Smart Box I/O automation system. This allows you to interface with automation components as well as automated fire alarm component systems to receive auxiliary commands for fleet all stops. So the question there is, if a fire were to break out in a facility and everybody is ushered right out, what happens to the robots? Do they keep moving? Do they keep doing things? And if so, do we have robots moving in and out of hazardous conditions with pallets full of who knows what, right? The answer is yes. You can create a fleet all-stop command through the SmartBox I/O system that can be taken from a fire alarm annunciator panel with the Vecna solution.
Okay, next question. Who is responsible for maintenance and repair on AMRs?
So that's a really good question because it can be answered in a couple different ways. There are some facilities that are fully outfitted and currently do all of their own forklift and automated material handling maintenance and repair, right? If that's the case, then there's a certain purchasing option like capital equipment purchase in which you can take ownership of an AMR fleet and you can be fully in charge of its uptick in maintenance. There are warranties attached to most AMR robotic units. Those warranties certainly exist in the first year and come along with the package, and then are optional in years 2 and 3, especially with Vecna Robotics. If you are going to participate in something called Robots as a Service program, which Vecna offers, then the maintenance and warranty contracts are actually rolled into that purchasing option. So in that way, you utilize an AMR supplier support network. So the people would be able to respond very quickly to any AMR fix-it needs, such as wheels that need to be replaced or motors that might have some sort of damage to them.
Okay. We have a few questions in the queue, but if you want to ask your own question, feel free to get in the queue right now. But here's the next question. If I'm using AMRs on my floor and I want to change what they do, what does that look like?
So a change depends upon the level and complexity of the task that you're asking. If you're asking an AMR provider to, let's say, add a specific drop-off or pickup location, in certain instances, especially with Vecna Robotics, you can actually have those changes performed remotely via teleoperating assistance and data link that exists, especially on the Vecna Robotics platforms. The maps that are created in which the AMR works in that space are of that given space or of the facility. So it's important when you get into a relationship with any of your AMR providers to find out what level of mapping they're going to give you for the facility and what future expansion looks like, because that will enable a more free and open conversation later on about whether or not you need to add another route or delete a route or turn one route off or on, which are all capabilities that exist. They can be supported remotely. In very rare instances would a new map necessarily need to be created.
Okay. More questions coming in. How do you avoid deadlocks?
So the old intersection standoff. What you're going to want to talk to your AMR provider about is fleet management. So the localization technologies that exist within each one of these platforms allow the fleet management system to understand where the AMR is with respect to the facility. Depending on how that manufacturer has mapped that facility and the level of complexity that the fleet management system can handle, you're now looking at the ability of the software to not allow the two robots to come into what we call a standoff, where one robot is trying to avoid the other one as an obstacle because that's what it sees it as within its sensor suite, and the other robot's doing the same. So they kind of do this dance with each other, but nobody ever gets out of the way. And that's actually taken care of by, in Vecna Robotics' specific instance, a fleet management system called Pivotal, which allows for one robot to slow up a little bit, let the other one pass, and then the other one can continue on its happy mission.
All right, another question. Is there a limit in the number of vehicles that can be handled by the system?
So that would depend upon your AMR manufacturer's capability and server specific IT requirements, right? So scalability is something that you're going to want to talk to any AMR manufacturer about. Scalability comes in multiple different conversations. One of them is the IT conversation, and the other one is the facility conversation. So is your facility large enough to support the complement of AMRs that is needed to do the work without creating traffic jams? Does the fleet management system allow for those traffic jams to be equated for, and does it get them around that? These are all questions that are on the facility side. Now, on the IT side, what you're talking about is how many AMRs are reporting into the central VPN or maybe a Wi-Fi network, right? And so you're talking about bandwidth, you're talking about traffic, and you just want to make sure that you've got the right resources in place in order for you to be able to run a fleet of 1 or 2 now, but scale up to those 10 or 20 later on.
Okay. Another question. Are AMRs able to work in an offline environment?
So this question is usually asked by folks who are interested in what happens if there's a network outage. And that's a really good question. An AMR receives a work order in some instances by a touchscreen command task, or in some instances with a fully integrated solution. What we mean by fully integrated is that AMRs can receive work orders from your WMS, ERP, or SAP systems directly as a bit command over the network. Instead of a human being actually interacting with the AMR itself and typing commands into the touchscreen about the job that needs to be done, instead it comes over the network and is seamlessly entered. Once an AMR has its mission, it now knows where it is and where it needs to go. And if that map's already created, then it's off on that mission. And around the course of that mission, if there's a network outage, the AMR will continue to complete that mission, and once completed, search for a new work order. If there's still a network outage at that point in time, the AMR will either come to an all stop or can be programmed in certain instances to return itself to a home position and wait for network instructions.
Okay, another question. Is there an ability to connect to the live data coming from the robot to create a countdown to ETA to a said job?
So what you're looking at there is called data analytics, and certain AMR manufacturers are going to be better at giving them to you than others. What you're asking is, okay, if I've tasked an AMR from point A, how long does it take to get to point B? And if I want to see how long it's going to be, can I look it up while it's in the middle of its route and kind of get an ETA? Those can be built into the software packages of some AMR manufacturers. They are predictive capabilities. They won't take into consideration anything that might be able to happen in that 20 seconds that you're waiting, right? So if it says ETA 20 seconds, and then somebody drops something or a trash can is moved into that AMR's way or something like that, does it have obstacle avoidance? If it doesn't, you're going to have to recover it. That's going to affect the ETA. But even if you do recover around that obstacle, that's also going to elongate the amount of time, right? So yes, the technology exists, but what is it going to tell you if we're also working in a dynamic environment?
All right, another question. Can a factory map be too large?
Oh, well, there's a deep hole in the middle of that question because there's a lot of information that needs to be asked by an AMR manufacturer when that question is asked. The simple answer is yes. Of course there is, because if we're talking about maybe the largest factory in the world, how much data are we taking back from that factory? However, this is also back to our IT conversation. What are your capabilities and resources for on-prem versus cloud service? And while the answer can be yes, it's very, very rare that you're going to find a facility that is so large that the data map is going to be outside of the capabilities for the AMR manufacturer to handle it, unless maybe they didn't future think themselves.
Okay. Another question. Do you get feedback from foremen who work with this kind of equipment? Do they have a preference?
So we do all the time, and it's part of our training process. The foreman is one of the most important individuals within that training process because they are the sergeant at arms, so to speak. Their adoption of the technology is one of its pass or fail criteria within the adoption of the technology in any use case. So I think what we find most of all is that a foreman wants to know that the technology is going to work. It's not going to be intrusive into their daily routine, making them have to change anything drastically, that it's going to be safe around them and their other workers, and most importantly, that it's not going to add another headache in their lives that day because, well, we all know from management, it's solving problems most of the time, right?
Yep. Okay. One more question. You hit some of the problems we have if we are using AGVs now, does it make a transition to AMRs easier?
Yes and no. So if you've got AGVs in your facility right now, chances are that you've got a pretty good understanding around, within the operator corps and the other workers as to what to do and not do around robots, right? So how can you walk in front of them and still be safe? What are the general tasks and things that you need to keep away from them? What are some of their limitations are going to be already known. So I see a current AGV user as somebody who's going to adopt an AMR technology a lot easier than somebody who has no automated material handling equipment, first and foremost. However, an AMR is now going to be a complement versus a path follower. So there are going to be new things that need to be trained on in the facility. So how to be in and around and task the robot, what the general safety bubble is around any AMR as it's currently working in the facility, what its capabilities to avoid obstacles are. And we all know that avoidance is great, but there are certain times where, there's just not enough room and you need to give it a little help if the aisle's not wide enough, for instance. And those are the things that you still need to train on. So yes, adoption's going to be easier, but no, it's not going to be, just a cinch pulling up the AGV and putting the AMR in.
Okay, we are caught up on the questions, but I want to give it a minute in case there's a late arrival, because we are a little bit ahead of schedule. If you have a question, now's the time to send it in. So anyway, again, this was a very interesting presentation. Just want to emphasize that, but I see no more questions coming in. So Andrew, thank you for the presentation. It was great. And with that, thank you for joining us today, and we hope you can join us for another SME Media webinar. Thanks again to Andrew for the presentation, and take care and stay safe, and talk to you later, everybody. Hope you can join us again for another SME Media webinar. Take care.
Thanks a lot.